Kettlebell CNC Maker Squad. So here we are again. So I just got word yesterday that the chipper shredder blades have been finished by the machine shop. So we should be getting those back soon. I don't have them back today. But this will be the beginning of the video where I start to work with them and install them. So in the meantime, I've got a bunch of other stuff that needs to be done. Let's see. Let's say, for instance, the lawnmower blades need to be sharpened. I need to change the oil on the lawnmower. I got a chainsaw that needs to be sharpened and a few other things. And I think we got some people coming over. A friend of mine, I'm going to interview him. He's looking at manufacturing engineering as a degree and working on his studies there. So we're going to maybe do a little interview there. Anyways, we'll get right to it, and here we go. Hey, so some other chores I did today. Checked all the tires on both the vehicles, and the one other thing I forgot to mention is I need to put the fender washers on the chassis, the bolts that mount the chassis, the engines of the chassis. Other than that, I'm just going to try and get as much done as I can. Okay, here we go. Alright, so hey guys, the reason why I did the lawnmower the way I did it, or when I did it, was because I'm going to need it. So what do you do with the lawnmower? I mean, it needed to be done anyways, but the lawnmower, I basically put stuff into the chipper and it gets shipped up and all that debris sort of piles up. And I use the lawnmower to sort of bag that material up so I don't have to shovel it off the ground. It's just an easy way of picking this stuff up. So, but of course the blades did need to be sharpened, the oil did need to be changed. But it's just sort of general maintenance, and it helps with that whole process of picking the material up once it's been shipped. Of course, if it builds up in big piles, then I'll have to shovel it, but for the most part, the lawnmower really helps with that. That's been my experience in the past. Anyways, the blades are back. I got them, and I'm going to be installing them. So let me show you real quick. I'll show you what's up with this. So why it had to be made the way it did. So if you can look real careful there, this angle right here had to be about 30 degrees. And the reason for that was because, okay, so let me show you this. Get a little bit up closer here. So you see that angle on that blade? that angle right there. This had to be 30 degrees because this thing mounts with this face on a plate, and it's got a slot in it that's right there. So this material, this blade spins around and it cuts material like that. And what gets cut, like let's say if it was my fingers right here, let's give another example here. Let's say here's the piece of wood that gets cut. So as this thing comes along, it cuts it, and it needs to scoop the cut material into that slot, so it pushes it through. And the angle of this lines up so that it comes right to that slot. If it was steeper, which is good, let me show you why. So the steel, if this blade edge is too thin and narrow, like more like a knife, then when it hits something hard, really hard, then it's just going to bend over. Of course, we got this stuff heat treated, so it should be extra hard. So there's sort of the two things in steel. It can be really hard, and when it's too hard, it becomes brittle, and it'll just crack, and like glass. Basically, it'll shatter, or pieces of it can break off. But if it's too soft, then it becomes bendable. And so you got those two problems with a sharp blade that's very thin like that, especially something like this that's on a flywheel that's spinning really fast and has a lot of force behind it, the power of an engine. This thing will hit that wood, and if the wood is too strong, it'll either bend the steel or crack it depending on the hardness of the metal. So there's some stuff going on there. We did need to get it heat treated, so it is harder because that does harden up the steel. It makes it a little bit more brittle, but there's sort of that transition as opposed to being too bendable, too ductile if it hasn't been hardened. So it sort of gets it closer to that threshold of being too hard but too ductile. It's really close to that that optimal threshold. So of course, but it does need to be this angle. So if this angle is too steep like that, yes, this blade will be stronger because there's more material behind it. It's not quite as thin, but the amount of material, if it's a steeper angle like this, the amount of material that can go through that slot is reduced. So I can't process as much material with the machine. So this is about as good as it can get. Let me show you with the blades. So let's go look at this. I mean on the flywheel. But there's the blade. There's the slot with the mounting holes. And this is where this mounts. Right on there, just like that. So you can kind of see it's covering up the slot. The blade is covering up the slot. So whatever gets cut by that blade gets pushed through that slot, right down through there. If this was too steep, then it cuts off part of the slot and blocks it from receiving material through it, which is why that had to be just like that. Had to be at that 30-degree angle. It's hard to see from here because of the darkness. Maybe if I was doing this in the summer, you'd see a little bit better. But that's why it has to be the way it is. Hopefully this is actually sharp enough, and I think it's going to be hard enough that we should be actually be okay. So I just got the mounting hardware for this, 5/16. I was able to find a place. I think it was Ace Hardware. Home Depot and Lowe's did not have 5/16 machine screws. And then I was able to get nylock bolts in addition to lock washers. And then I've got Loctite as well. So those bolts, they're not coming off. This thing is going to stay on there, and I'll never lose these blades unless maybe the bolts shear off. But being they're 5/16, I don't see that happening. Maybe if it was, 1/4 inch, I've actually sheared those off by over torquing the nuts. But 5/16, I don't see that breaking. I think it'll be okay. I think the original bolts on this thing were 5/16. But let me get to it. I'm going to go ahead and mount this stuff and get things assembled so that tomorrow, when I get off work, I can come home and I can start running this thing and do a good solid test run in the back and put some material through this, soft material, hard material, intermediate material, and just make sure that it really holds this edge and this thing is strong enough. So I'm going to go ahead and do that and sort of prep for tomorrow, and we'll just get right at this. Okay, here we go. All right, here we go. Test number 2. New blades, hardened steel, temperature treated. So I'm gonna really give it a go this time and see if it works with a lot of material, and it should hold up. But we'll see for sure. This is the real test. Well, I think it works, but I gotta get this log out of here. I think it works, but I got a log stuck in there. I was supposed to use that to jam stuff down, but it got stuck. So I'm gonna pull the hopper off and take that thing out, and then I can proceed. So here we go. I'm gonna keep going. Alright, so it seems to have worked. I went through like half a wheelbarrow load, or maybe it was a full wheelbarrow load. Maybe not a heaping wheelbarrow load, but it was a wheelbarrow load of wood cuts and logs and chips and all kinds of hunks of wood that needed to be chipped up into fine mulch. So I went through that material. I actually picked out like some of the hardest pieces of wood that I could find out of that pile in the back, just to provide like a real good test. If it survived that, it's going to survive anything I throw at it from that pile. So yeah, I guess I'm just going to clean up right now. It's got some water stuff on it from the snow. You saw the snow falling. It was really cold. So I'm just, like I said, I'm just going to try and clean it up so it doesn't get all rusty and stuff, because I still need to paint it. Turn the fan on up here so that it helps it to dry out, so I don't get too much rust going on. And then I got to start disassembly. I need to check and validate that the blades are still sharp, and just see just how much all that work that I just did doled out. So that'll be sort of my analysis. I'll do what I got to do in my next video, and we'll sort of clean up and do like a final assembly. Like I said, I think it's working really well, and we're just going to validate that. But I would call success number 2. I call test number 2 a success. So I guess this is me signing off for now. See ya.